Hello, in this clip I would like to introduce shortly project planning. So what is project planning? Well, project planning is relevant for the production of unique items and whatever these items are. So it could be new product development, it could be an IT project, it could also be building a house or some type of boat. And we assume that every project consists of multiple tasks or activities and that they have some complicated dependencies. So before you can start on one thing, you might have to finish multiple others. No? Makes sense. If you build a house, then you first have to put the foundation and the walls before you can do the interior, for example. Yes. And the goal is of project planning is to calculate the earliest finish time. When can I finish the overall project? Knowing the task times and knowing also their dependencies. Now, project planning is part of the bigger subject of project management, and if you do project planning, then you should ask yourself if the project is successful or if you just successfully manage the project. Yes, and if you all know this building, it's the Sydney Opera House, and the Sydney Opera House actually costed 14 times more than originally scheduled. They were really late on their project planning. They were 10 years late, but everybody knows it, and now it's the symbol of Australia. So a project can be very successful while the project management and especially project planning really goes wrong. Yes, a project is not only successful if you finish on time; it's also when the objectives of the project are met. Yeah? But we will focus on project planning, and we will see that project planning, which you do for one-time items, is much more difficult than the planning of production and production scheduling and production planning. And why is that? Because there's typically no data. You do it only once, you only build this opera house once, and therefore you do not know how long the different tasks will take. And this is of course to the contracts. If you produce cars, then you're perhaps producing your 1000th car and you have data on the previous 999 ones, and with that you can have estimates of how this production will go. So this lack of data, that of course introduces randomness, but first we are going to look at project planning without randomness, the basic theory of that, and then we'll move on to randomness, but that will be outside of this clip. So we need to get to the definitions. You have capital N activities, they have durations, DI. You have order relations, you have no cycles. We assume that number 1 is the start node, number N is the end node. If there are multiple start nodes or multiple end nodes, then you can always add an additional node, which is the unique start or end node. So that's always possible to do it in this way. And we assume that, actually the structure is more complicated than that of the bill of materials in production scheduling in MRP, because if you have a bill of materials, it's a tree-like structure, but here you can have more complicated structure. You can get a graph representation of that. We'll see an example in a minute. And the early finish time of node I is indicated by EFI. And now we're interested in how can you calculate this. Well, there is actually this simple formula. The earliest finish time of a certain activity is its duration plus the earliest finish time of all its predecessors. Yes, and the earliest finish time of the whole project is the earliest finish time of the end node. So that's pretty simple. So here an example. Here you see 6 activities. 1 is the start, sometimes called the source. 6 is the end node. And now here you see the D's, the durations, the arrows indicate the precedence relation, so the earliest finish time. We assume that you start at 0, so the earliest finish time of this activity is 1. Then This one, it has one predecessor, so duration 2, earliest finish time of predecessor is 1, it's 3. Well, you can see it all going on here. A non-trivial one, one less trivial one is 5, because it's really a simple algorithm. You have the duration 3 plus the maximum of the end time of these two, its predecessor, so that's 2 and 3, so the maximum of 2 and 3. So you get 3 plus 3 is equal to 6. So this is a simple algorithm to determine the earliest finish time. But you can also think of a linear programming formulation of that. And the idea is that in the assignment you will use a linear programming formulation of this problem. Thank you for watching.